Hello, hi everyone, welcome back to my channel. So for today we're going to proceed with multi-degree of freedom system. I hope by now everyone have fully understand how to solve 2 degree of freedom in order for you to construct the equation of motion, how to find the natural frequency, and how to draw the mode shape. So for multi-degree of freedom system, it can be 3 degree of freedom system, 4, 5, and so on. So there are 4 approaches that we can use to solve multi-degree of freedom system. First is by using the Newton's second law for a spring mass system. Second is by using eigenvalue and eigenvector. Third approach is by using generalized coordinates and generalized forces. And fourth one is by using Lagrange equation. And for this session, I'm going to focus on the Newton's second law approach. So let's focus on example 3. I hope by now you already know the degree of freedom for this problem. So remember, in order for us to determine the number of degree of freedom, it will be number of mass multiplied by number of possible direction or axes. So we have 3 masses here, m1, m2, and m3, and we have one single direction which is on x-axis. So this will be a 3 degree of freedom problems. So the example asks us to determine the equation of motion, the natural frequencies, and mode shape of the system. And given that k1 is equals to k2 is equals to k3 is equals to k, and m1, m2, m3 is equals to m. So how are we going to solve this? First, we're going to solve the equation of motion. We're going to construct the equation of motion. Right. In order for us to construct the equation of motion, okay, basically first thing you need to do is you need to draw the free body diagram. So remember, for free body diagram, start it with the mass. So we have 3 masses here. We have m1, we have m2, and we have m3. So let's focus on the first mass. Okay, for the first mass, the reaction would be due to K1 on the left hand side and K2 on the right hand side. So we will have 1 here, K1 x1, okay, and then K2 will react with x1 and also with x2. So there will be 2 here. Look at the direction. The direction of the masses for all the masses is going to the right hand side. So we need to assume moving to the right is positive. We know that the reaction K1x1 is always opposite to the movement or the direction of mass 1. So since it is opposite, since the mass is moving to the right, so K1x1 will go on the opposite direction, which is to the left. How about K2x1? We know that the mass is moving to the right, so K2x1 will go opposite direction, K2x1 here. And then for K2x2, because this one will react with x2, So we just put here first k2x2, but we are not sure of the direction. Leave it first. Right, now let's focus on the second mass, which is M2. Okay. There will also be 4 direction for mass 2, or 4 reaction, which is due to K2 and also due to K3. So here there will be K2x1, K2x2. And on the right hand side, there will be K3x2, K3x2, and also K3x3. Alright, in terms of direction for mass 2, okay, for K2x1, since for mass 1 is moving on the left, so it will be opposite direction for this one, then it will be going to the right. How about K2x2 here? So for K2x2, since the mass is moving to the right, okay, K2x2, since the mass is moving to the right, therefore the reaction for K2x2 will always be opposite to the direction of the mass, and it's going to the left. So in here, if it's moving to the left, for mass 1, it will be also opposite. Okay, how about K3x2? For K3x2 here, since the mass is moving to the right direction, so the reaction will always be opposite, and it will be to the left. So in here, if it's going to the left, this one will be opposite with this one. Okay, and then for K3x3, okay, for K3x3, since mass 3 is moving to the right direction, therefore the reaction will always be opposite. So for K3x3, for mass 3 will be going to the left, and for mass 2 it will be opposite of mass 3. So basically this is the free body diagram of the system. Now we want to construct the equation of motion. So since the direction of the mass is to the right hand side, so we assume going right hand side is positive. Therefore sigma f equals to mx double dot. Okay, now let's start with mass 1. Okay, mass 1, you see there is how many reaction is applied on mass 1. There is 1 here, 2 and 3. So m1 x double dot 1 is equals to minus k1 x1, because k1 x1 is moving to the opposite direction of the mass, minus k2 x1 plus k2 x2. Okay, so we bring everything to the left. m1 x double dot 1 plus k1 x1 plus k2 x1 minus k2 x2 equals to 0. We factorize m1 x double dot 1 plus k1 plus k2 x1 minus K2 x2 is equals to 0. So if you look back here, we've got one reaction here, 2 and 3 from S1. So 1, 2, 3, that means it's correct. Okay, now let's focus on the second mass, which is M2. How many reactions we have? We have 4 reactions, 1, 2, 3, and 4. So M2 x double dot 2 is equals to positive K2x1 minus K2x2 minus K3x2 plus K3x3. So bring everything to the left. M2x double dot 2 minus K2x1 plus K2x2 plus K3x2 minus K3x3 equals to 0 because there is no force, so that's why it equals to 0. Okay, we factorize M2x double dot 2 minus K2x1 plus K2 plus K3x2 minus K3x3 equals to 0. So that's all for the second mass. Okay, how about the third mass here? For the third mass, we only have 2 reactions. Okay, for the third mass, we only have 2 reactions, just this one and this one. So for the third mass, M3x double dot 3 is equals to K3x2 is positive because it's moving to the right, minus K3x2. So bring everything to the left, M3x double dot 3 minus K3x2 plus K3x2 equals to 0. Alright, so for the equation of motion, we already have all of the equation. So we know that the matrix will be in a form of M x double dot because it's a spring mass system plus kx. There's no damper, so it's only the spring matrix equals to 0. So we've got 3m here. So the equation of motion will be m1 0 0 0 m2 0 0 0 m3. We have x double dot 1, x double dot 2, x double dot 3 plus, let's look at the first one. We only have k1 plus k2 on x1 and minus k2 on x2. So it will be k1 plus k2 and then minus k2 minus k2. Let's do it this way so you can understand well. x1, x2, x3 equals to 0. So in here it will be 0 because there is no x3 in here, so that's why it becomes 0. Okay, we only have x1 and x2 here. Okay, so for the second one, it will become this one, and this one acting on x1, x2, and x3. So minus K2, K2 plus K3, and the third one is minus K3, minus K3. Alright, for M3 we only have K3 acting on X2. Sorry, I think it's wrong here. This one should become K3X3. Sorry for the mistake. Okay, because here it is K3X3. Okay, so it become 0 here because there is no x1 term for mass 3. There's no x1 term, so it becomes 0. Minus K3, and here K3. Okay, I hope all of you should know by now how to construct this one. This is the reason why I gave you the previous assignment, in order for you to understand well how to construct the equation of motion. Okay, now always remember, okay, if you have the value, let's say we have here, we have all the values, so replace it in the matrix in your equation of motion. So we know that m1, m2, and m3 is equal to m, so this will become m, sorry, I just use green, m 0 0 0 m 0 0 0 m. Okay, why we replace it with m? Because it's already given in the question that k1 equals to k2 equals to k3 equals to k, and m1, m2, m3 is equals to m. So always remember, if let's say they give you the value, if let's say they give k1 equals to 4, k2 equals to 5, m1 equals to 6, m2 equals to 7, always remember, after you have construct the equation of motion in matrix form, replace the value straight away in order for us to will be easier for you to solve it. But for this case, since it only give in the terms of k and m, so just replace straight away. That become x double dot 1, x double dot 2, x double dot 3 plus, we know that k plus k1 and k2 both are k, so it will become 2k, k plus k is 2k, minus k 0, minus k 2k, minus k 0, minus k k, x1 x2 x3 equals to 0. Right, so this is the equation of motion in matrix form. Now we're going to move on how to determine natural frequency. First, need to assume harmonic motion. X equals to a sine omega t plus phi, and x double dot is equals to minus omega squared a sine omega t plus phi. So from the matrix m 0 0 0 m 0 0 0 m, okay, I place straight away minus omega squared a1 minus omega squared a2 minus omega squared a3. I place straight away after I assume the harmonic motion, plus 2k minus k 0 minus k, 2k, minus k, 0, minus k, k, a1, a2, a3 equals to 0. So solve this one. Okay, solve this one. That become 2k minus m omega squared. Second one would be minus k. Third one will become 0. Okay. I hope all of you, I expect all of you should know that at this rate and how to solve this here. Minus k. Third one would be 0 minus k, k minus m omega squared. Solve all of these, yeah. That become a1, a2, a3 equals to 0. Alright. So if you have values in here, it will be easier. But since you don't have values, so we need to let lambda is equals to m omega squared over k. Okay, why? Why we need to assume that lambda is equals m omega squared over k? Because we have too many unknowns here. So we have too many terms here. We have the terms k, we have the term m, we have the term omega. We want to simplify everything. So in order for us to let lambda is equals to m omega squared over k, we need to divide all of these matrix with k. Okay? If we divide everything by k first, okay, so it becomes 2 minus k. You divide everything by k and assume lambda is equals m omega squared over k. Okay, so it will become 2 minus lambda minus 1, 0, minus 1, 2 minus lambda minus 1, 0, minus 1, lambda minus 1. So basically from here, okay, because we want to simplify too many terms here, okay, divide everything by k, okay, divide everything by k, and then after that assume lambda is equals to m omega squared over k. Okay, so I'll just show you if from this one, okay, from all of this, if I divide by k, what will happen is that we will get 2 minus m omega squared over k. Actually, I don't plan to show you this, but I'm worried that some of you might not understand. This one become negative 1 because I divide everything by k. This one becomes 0 minus 1, 2 minus m omega squared over k minus 1, 0 minus 1, 1 minus m omega squared over k. Okay, basically, if I divide everything in here by k, okay, this is what I will get. So, and then we let lambda is equals to m omega squared over k. So we know that here we have the term of m omega squared over k, m omega squared over k, m omega squared over k. So assume all of these as lambda, okay, and then it will turn into this. Okay, so moving on. Okay, and then sorry, I become a1, a2, a3, is equals to 0. Okay, and then from here we need to use Serre's rule in order to find the determinant of what is lambda. Okay, this is why we need to simplify. Okay, so proceed using Serre's rule. Okay, for those who don't know what is Serre's rule, you can refer back to my videos in the YouTube. So using Serre's rule, okay, I write it back again in order for you to see it more clearly. 0 minus 1 minus lambda minus 1, 0 minus 1 minus lambda. I just write back the one previous here. Okay, you don't need to write it 2 times. This is to make everyone easier to see. Okay, basically I just write back in order for you to see how we're going to use Serre's rule. Okay, so using Serre's rule, okay, what we will get is that we will get 2 minus lambda 2 minus lambda multiplied by 1 minus lambda minus negative 1, negative 1. Okay, that is for the first one, okay, which is this one. Okay, and then now we'll focus on the second one here. Okay, so remember, second one will be negative minus negative 1, because in here is negative 1. Okay, the remaining is this one, this one, this one, and this one. So it becomes minus 1 multiplied by 1 minus lambda minus 0, because this one multiplied by this one will become 0. Okay, and then the third one is this one. Okay, if we take that the third one, the remaining will be this one. But since it is 0, so plus 0, and there is no point for you to multiply this one because it's 0 in front. See, so whatever we multiply by 0 will become 0, so just keep that one, and it become, so this is equals to 0. Okay, so this is totally maths. Okay, totally maths. 2 minus lambda. Okay, solve in the part. 2 minus 2 lambda minus lambda plus lambda squared minus 1 minus negative 1 minus 1 plus lambda equals to 0, and 2 minus lambda lambda squared 3 lambda plus 1 plus lambda minus 1 equals to 0, and then it becomes 2 lambda squared minus 6 lambda plus 2 minus lambda cubed plus 3 lambda squared minus lambda plus lambda minus 1. equals to 0. Okay, so what I normally do is that, okay, I always write the first biggest term, which is this one. Okay, we only have one terms of lambda cube, this one, so negative lambda cube. Okay, and then look for the second biggest. It will be lambda squared, which is this one, so it will be plus 3 plus 2 is 5 lambda squared. And then the third biggest is only lambda, so it become minus 6 lambda plus 1 equals to 0. Okay, just want to recap, okay, from here. Because we don't have the values of m and k, we only have in the terms of k and m. Okay, we don't have values, we don't know k is either equals 4 or m equals to 5, for example. Okay, so that is why we need to use the lambda approach. But if you have the values for k and m, okay, replace it straight away in this, so that you don't need to use the lambda approach. I hope all of you understand, yeah? Okay, but for this example, since we don't know the value of k and m, that's why we need to use the lambda approach. So now this is how we're going to find the lambda. Okay, so basically we can use our calculator straight away. Okay, so using calculator, okay, always remember that you will get three values, lambda 1, lambda 2, and lambda 3, and make sure straight away you organize it so that lambda 1 should be smaller than lambda 2, should be smaller than lambda 3, because you need to remember that omega 1 is always smaller than omega 2, and omega 2 is always smaller than omega 3, so it's the same. Okay, straight away rearrange it. Okay, so from the calculator I'll get lambda 1 equals to 0.1981, lambda 2 is equals to 1.555, and lambda 3 is equal to 3.247. Okay, so we know that previously lambda is equals to m omega squared over k, because the question asks you about omega. Okay, natural frequency didn't ask you about lambda, so we need to find what is the omega. From here we know that omega squared is equals to lambda k over m. Therefore, omega is square root of lambda k over m. Okay, so from the value of lambda, okay, you can find omega 1, omega 2, omega 3 in terms of the terms m and k. So using calculator I'll get omega 1 equals to 0.4451 square root k over m. Omega 2 is 1.247 square root k over m. And the third one, 1.802 square root k over m. Okay, please try to do this again, okay, in order for you to understand better. So basically this is the answer for the natural frequency. Okay, now third one, moving on, we're going to find the mode shape. Third one, it asks about mode shape. So recall back the previous metric. Okay, I hope all of you should know by now. Okay, so use this one. Okay, I'll write it back again. So for mode shape, 2 minus lambda minus 1, 0, minus 1, 2 minus lambda minus 1, 0, minus 1, 1 minus lambda, a1, a2, a3 equals to 0. Okay, this is basically how I do it. Alright, in order for you to find the mode shape, you need to remember that, let's say if I want to find the first mode shape, okay, first mode shape is a1 over a1, a2 over a1, and a3 over a1. For any mode shape, okay, the mode shape will become like this: a1 over a1 for the first one, second a2 over a1, and a3 over a1 for the third one. So we need to find the ratio from this. Okay, so from this matrix, okay, know that 2 minus lambda a1 minus a2 is equals to 0. Let's write it as first equation. Okay, first equation from here. Okay, okay, now let's move on to the second one. So minus a2 plus 2 minus lambda a2, sorry, this is minus a1, a2 minus a3 is 0, second equation. So the third one will become minus a2 plus 1 minus lambda a3 equals to 0. This is the third one. Okay, so for us to find the ratio, okay, in order for us to find a1 and a1, we don't need to find the ratio because we know that it will become 1 straight away. For a2 over a1, okay, we can use this one, okay, because from 1, so from the first equation, you know that 2 minus lambda a1 is equals to a2. So a2 over a1 is 2 minus lambda. Okay, so we have solved this one and we have solved this one. How about a3 over a1? So in order for us to find a3 over a1, there is so we basically, in order for us to find a3 over a1, we can use this first equation and second equation, okay, but we need to ensure that we need to get rid of the term minus a2 here. So this is actually, again, this is totally math, okay. So if let's say I make equation 1 minus 3, okay, that means if I take equation 1, okay, I minus equation 3, so basically what will I get is that 2 minus lambda a1 minus a2 plus a2 minus 1 minus lambda a3 is equals to 0. Okay, if you look here, because minus a2 plus a2, then it becomes 0. So we only left with 2 minus lambda a1 is equals to 1 minus lambda a3. So a3 over a1 is equals to 2 minus lambda over 1 minus lambda. Alright, so we have solved a2 over a1 and a3 over a1. And then if you want to find the mode shape, okay, so for recall back the value of lambda. For lambda 1 is equal to 0.1981. Okay, the first mode, x1. Okay, I write this just for you to understand better. Sorry, a1 over a1, a2 over a1, a3 over a1. Okay, you don't need to write this one, but you just straight away write the answer. Okay, so replace the value of lambda. Okay, for lambda 1, 0.1981, replace it in this one and this one. Okay, so straight away you will get the answer. So for the first mode shape, it will become 1.8019, 2.247. Okay, that is the mode shape for the first one. Okay, for the second mode shape, okay, we need to use the second lambda, which is lambda 2 for the second mode shape, 1.555. So the second mode, x2 is equals to, okay, replace again this value in this equation. Okay, replace it in here. Straight away you will get the value 0.445 negative 0.801. Okay, and the third mode shape, you use the third lambda value. For lambda 3 equals to 3.247. The third mode shape, x3 is equals to 1 minus 1.247, 0.555. Alright, so basically this is the mode shape for the system. So if the question didn't requires you to draw the mode shape diagram, okay, you only write up to this. But if it asks you to draw the mode shape diagram, then you need to draw the mode shape diagram. Okay, so I assume all of you already know how to draw the mode shape diagram. Okay, please review back what I've taught you. Okay, especially this one. I think if you already understand well for second degree of freedom, you won't face any problem. Okay, the tricky part is only to get the ratio of a2 over a1 and a3 over a1 from the matrix here. Okay, all right, thank you very much. Hope to see you again. Thanks, bye.